Next topic, triode AC switch, that is TRIAC. So the term TRIAC is derived by combining the first three letters of the word triode and the word AC. So a TRIAC name came. Here a TRIAC is capable of conducting in both the direction. So here bidirectional thyristor with three terminal. It is widely used for control of power in AC circuit. Here they represented structure of triac, circuit symbol, and IV characteristics of triac. Now we can see the construction of triac. So depending upon the polarity of the gate pulse and the biasing condition, the main four-layer structure that turns on by a regenerative process could be one of P1N1, P2N2, P1N1, P2N3, or P2N1, P1N4 as shown in the figure. So the advantages of TRIAC are it can be triggered with a positive or negative polarity voltage. They need a single heat sink of slightly larger size. They need a single fuse for protection, which simplifies their construction. So in some DC application, the ACR has to be connected with a parallel diode for protection against reverse voltage, whereas a TRIAC may work without a diode. A safe breakdown in either direction will be possible. So disadvantages of TRIAC are nothing but TRIAC will have low change in voltage with respect to time rating compared to ACR. Since TRIAC can be triggered in either direction, the trigger circuit with the TRIAC needs careful consideration. So reliability of TRIAC is less than that of SCR. So application of TRIAC or here TRIAC used as a bidirectional thyristor for various applications. So it can control the speed of single phase AC series or universal motor. It is used in food mixer and portable drills, and also used in lamp dimming and heating control. It is used in zero voltage switched AC relay also. These are the points to remember for TRIAC. Now we are going to see the field effect transistor, that is FET. So field effect transistor is a semiconductor device which depends for its operation on the control of current by an electric field. So field effect transistor has several advantages over BJT. First one, current flow will be due to magnetic carriers only. This is immune to radiation, high input resistance, less noisy than BJT, no offset voltage at a zero drain current, high thermal stability. This is the symbol of JFET for N channel and P channel. So for N channel, it will be towards the gate, P channel outward the gate terminal. Classification of FET is given here. So FET is classified into two types, JFET and MOSFET. So further, JFET is classified into N channel and P type channel. MOSFET is classified into two types, depletion and enhancement type. So each type further classified into P type and N type channels. So based on the construction of JFET, we have two types, that is N channel FET and P channel FET. So this is the construction of JFET. So in construction of N-channel FET, the two ends of the bar are known as source and drain. So third one will be gate. So here the source is the terminal through which majority carrier enter the silicon bar. Drain terminal through which majority carrier leave the bar. So gate will control the drain current and is always reverse biased. So analogy of FET is given here. So the operation of FET can be compared to the water flow through a flexible pipe. When one end is pressed, the cross-sectional area decreases, hence the water flow will decrease. Similarly, in the FET drain FET drain will act as the outlet. Gate will be similar to your control in the figure 2. So the outlet will be drain, inlet will be source. The control will be given in the gate terminal. So when the pipe is pressed at one end, water flow will be decreased. In a similar manner, when we press the gate terminal, that is when we control the gate terminal, the flow of current will be decreased at the drain terminal. The principle behind the FET is to control the drain current. FET makes use of channel formed in by space charge region between gate and the bar. So by increasing the reverse bias, the width of space charge region will be decreased. As a result, the channel resistance increases, the drain current will be decreases. So here we can see the reverse bias increasing on gate terminal. So the channel width goes on decreasing when reverse bias on gate is increased by battery 2. Here the bias voltage at which drain current becomes 0 is also known as pinch off voltage. So this is the difference between N channel FET and P channel FET. So here source will be connected to the negative terminal, but in P channel it will be connected to the positive terminal. Drain terminal connected to positive and drain is connected to negative in P type. In N type, gate connected to negative, there is reverse bias. But here gate is connected to positive and a forward bias, sorry, reverse bias. So when voltage is supplied between source and drain, majority carriers move through the channel between depletion region. The value of drain current is maximum when no external voltage is supplied between gate and source. When the gate to source reverse bias increases, the depletion region will widen and channel width decreases, hence drain current goes on decreasing. When the drain current decreases, gate to source voltage will be increased further. The channel completely closes. This is said to be pinch off region. So which will reduce the drain current to 0. Here the gate to source voltage at which the drain current is 0 is said to be pinch off voltage. This is P-type and N-type FET comparison based on the current and mobility of electrons. The mobility of the electron is almost twice that of holes in the N channel. Here the mobility of hole is very poor. Here in N channel current carrier will be electron. In P channel it is hole. Here noise will be very low in the input, but in P channel low transconductance and noise will be very more. So these are the JFET parameters. So DC drain resistance, AC drain resistance and transconductance are the important parameters which is obtained from the characteristics, that is the electrical behavior of the JFET. So DC drain resistance is defined as the ratio of drain to source voltage to drain current, also called as static or ohmic resistance. Mathematically we can represent as RDS equal to VDS by ID. Then AC drain resistance is defined as the resistance between the drain to source when JFET is operating in pinch off region or saturation region, that is given by RD equal to del VDS by del ID when VGS is constant. Next is transconductance, which is given by the ratio of small change in drain current to the corresponding change in gate to source voltage VGS, which is also known as forward transmittance. It is given by the formula GM equal to del ID by del VDS. So this is the difference between FET and BJT. So FET is a unipolar device, but BJT is a bipolar device. It is the voltage control device, that is the current control device. Here the input impedance will be very high, but there it will be very low. Better thermal stability here. There low thermal stability. Switching speed will be high in FET, but in BJT switching speed is low, less noisy here. They are more noisy. It is easy to fabricate in FET, but it is difficult to fabricate on IC BJT. The next, drain characteristics. Drain characteristics shows the relation between drain to source voltage as well as drain current. So here you will have three different types of region: ohmic region, pinch off region, avalanche breakdown region. So in the drain characteristics, in the VDS, voltage drops corresponding to point B. Channel width also reduces to a minimum value, which will be known as the pinch off region. Here the ID current will be equal to IDSS into 1 minus VGS divided by VP whole square. Here the device may get damaged due to avalanche breakdown mechanism. So disadvantages of FET over BJT is, here the main drawback is gain bandwidth product will be very small compared to your BJT. So features, the high input impedance, low output impedance and low noise level will make the FET for superior over the bipolar. Then applications of FET are, it will be used as a buffer which will isolate in the preceding stage. It can be used as a phase shift oscillator for its high input impedance advantage to minimize the loading effect. In voltmeter, it can be used as a high input impedance device, which will be useful at the input stage. This is the symbol of JFET, that is the N channel JFET and P channel JFET. Thank you.